Hello, class. Welcome to our new module in 8th grade Eureka Math. We're in Module 7. This is Lesson 1. So let's get started on the last module for 8th grade Eureka Math. The first lesson is called the Pythagorean Theorem. We have talked about the Pythagorean Theorem earlier this year. Today we're going to review it a little bit and use it to introduce us to some things like square roots. So you'll need pages 1 through 13 in your Module 7 books. Get those out, and let's begin our notes for today. Starting with vocabulary, we have 4 vocabulary terms that we're going to talk about today. First is the Pythagorean Theorem, just a little bit of a review so that you have something to look at and remind yourself about in these notes. So the Pythagorean Theorem is an equation for the relationship between side lengths of a right triangle. So the Pythagorean Theorem is all about side lengths. It's all about right triangles, and it shows how the lengths of the sides are connected. And this is the equation right here. A squared plus B squared equals C squared. So that's the equation. When you're solving this equation, it's important that you remember that A and B are the leg lengths and C is the hypotenuse length. You always want to put the sides in the right location. So the hypotenuse is always C. The hypotenuse is always C. Never confuse the hypotenuse and the legs. You will make bad decisions. You'll find incorrect answers for your work. So hypotenuse is always C right there. I do have the definition of legs and hypotenuse for you so that you can have those again. Legs are the right triangle sides connected to the right angle. So they are the right triangle sides that are connected to the right angle. The hypotenuse is the right triangle diagonal side that is opposite the right angle. So very important, you know what the legs are, what the hypotenuse is in a right triangle. And remember, this only works for right triangles. Our last vocabulary term is converse. Converse is the reverse of a process. So the Pythagorean theorem, like this, that's in the standard orientation. This is the standard way we do it. We take the legs and we find hypotenuse. The converse would be when you have a leg and the hypotenuse and you need to find the other leg. So converse is the reverse process of solving something, of doing something. So those are our 4 vocabulary terms. If you need more time to copy down the definitions, pause the video now and copy them down. But let's talk about what we're going to be doing today. Today, we will review how to find missing side lengths of right triangles. So like I said, we've done the Pythagorean theorem before. Today, we're going to review it, practice it some more, and look and understand it deeper than we have in previous modules. So we're going to still find missing side lengths of right triangles using the Pythagorean theorem. And I do have some notes for you today. Here are the notes, just as a reminder about how the Pythagorean theorem works. Here's our triangle. The legs are the sides that are connected to the right angle. Here's the right angle. So the legs are connected. Here's leg A, leg B. The hypotenuse is the diagonal that is opposite the right angle. So this is the hypotenuse. It is diagonal and it is opposite from the right angle. It is not connected to the right angle. The legs are connected to the right angle. The hypotenuse is not. And so you use this, the Pythagorean theorem, a squared plus b squared equals c squared, right here. So there it is. This is what it is. That's the theorem we use if the hypotenuse is missing. The converse of the theorem, remember our vocabulary word, the converse, if a leg length is missing, I use this version of the theorem. It's the same thing. I just use the subtraction proper of equality to put the missing leg, to isolate the missing leg term. So in the regular theorem, the hypotenuse is isolated. In the converse, a leg is isolated. Same theorem, I just used the subtraction property of equality to change this into this. But both of those work. This is the Pythagorean theorem. This is a right triangle. This is the relationship between the sides. Now, let's practice this a little bit. Let's do some work starting in our pages. Starting on page 1, let's look at how the Pythagorean theorem can be used. So, first thing that they want us to know is that these figures are not drawn to scale. Now, not drawn to scale means don't even try using a ruler to compare or try to make guesses. Do not say, oh, that looks twice as long, so I'm going to just multiply by 2. Not drawn to scale means you cannot trust your eyes. You have to do the math to find it. So let's do the math. Example 1. Write an equation that allows you to determine the length of the unknown side of the right triangle. So we need to find the missing side. Well, that is doable. We have a right triangle right here. There's the right angle. Let's find the legs. I know the legs are connected to the right angle. So we have a leg, and opposite the right angle, the diagonal, is the hypotenuse. So now, what is missing? It looks like a leg is missing. I can say this is leg A, this is leg B, and this is hypotenuse C. So when the leg is missing, remember in our notes, when the leg is missing, I'd use this. C squared minus A squared equals B squared. C squared minus A squared equals B squared. So I can do this. I'm going to say, oh, let me show you how I got it. First, we start the Pythagorean theorem with A squared plus B squared equals C squared. But in this one, I need B. So let's do the subtraction property of equality to take A squared away from both sides. Gives me B squared equals C squared minus A squared. Now to write the equation, I just need to substitute what I have. So B is just going to stay B because that's the missing one. C is 13 right here. So 13 squared minus A squared. A is 5. So 5 squared. Now I have B squared equals 13 squared minus 5 squared. You can use your calculator for this if you like, but 13 squared is 13 times 13. 5 squared is 5 times 5. So I get B squared equals 169 minus 25. So B squared is 144, which means B squared is 144, which means B equals 12. Because we've done this before, but B squared means B times B, and 144 is 12 times 12. So 1B is 12. That's our answer. B equals 12. That's the answer, B equals 12. But really for this equation, for this example, they just wanted the equation. So all you really need to do is you probably could have stopped like right here. Because it just asked you for the equation. I did a little bit extra by solving the equation, but it just wanted the equation. It just wanted you to be able to use the Pythagorean theorem or show how the Pythagorean theorem can be used. So let's try this again. Let's do another example showing how the Pythagorean theorem can be used to find a missing side. So we have this example 2. write an equation again to find the missing sides? Well, again, we need to, when we have a right triangle, we need to think, where are the legs? Where are the hypotenuse? So here's the right angle. And remember, the legs are connected to the right angle. So this side and this side are the legs. Excuse me. The hypotenuse is not connected, is opposite the right angle. So that's the hypotenuse right there. We can even label them with our letters if you want. Remember, the legs are A and B, and the hypotenuse is always C. Then we can use the Pythagorean theorem to solve for this, to find an equation for how to solve this. So we know the Pythagorean theorem, like in our notes, is a squared plus b squared equals c squared. So we know a is 4, so 4 squared, plus b, which is 9, 9 squared, equals the unknown c squared. So this is our equation right here. So we can actually probably stop right here if we want to, because it just said write an equation. But if you want to keep going, we can keep going. So we get 4 squared, which is 4 times 4, plus 9 squared, 9 times 9, equals c squared. 4 times 4 is 16. 9 times 9 is 81, equals c squared. 16 plus 81 is 97, equals c squared. And that's as simple as we can get it. We cannot simplify c squared equals 97, at least not yet. Later in this module, we're going to learn about how we can simplify that more. But right now, that is just where we're going to stop today. So this shows us, this helps us understand right triangles more. This is the purpose of the Pythagorean theorem. Those are 2 examples about how to use the Pythagorean theorem. Just remember, a squared plus b squared equals c squared, and c is always the hypotenuse. So practice finding the hypotenuse, practice finding the legs, try to memorize Pythagorean theorem, and use your properties to simplify and solve. Let's see what we're doing next on page 2. Oh, example 3. So why don't you try example 3 on your own right now? Pause the video, try example 3, see if you can write this equation for this right triangle, and then unpause the video when you are ready to check your work with mine. Okay, so hopefully you took a minute. You should have identified the pieces. So here's the right angle right here. So the legs have to be connected. So here's a leg, and here's a leg. The hypotenuse is not connected. It's the diagonal that's opposite. So it's over here. You should have even labeled it with the letters, like A can be that leg, B is that leg, and the hypotenuse is always C. And then you should have taken the Pythagorean theorem and you should have used it to write the equation to find the missing side length. So the Pythagorean theorem is a squared plus b squared equals c squared. And then we just substitute. A is 8 centimeters. And here's another thing I can tell you. It really does not matter which leg you say is A and which leg you say is B, because we're just adding them, and adding the order does not matter. So you can say 8 is A, or you can say 3 is A. For the legs, it does not matter what order. The leg order in the Pythagorean theorem does not matter. The important part of the Pythagorean theorem, the hypotenuse is always C. A leg is never C. But a leg can be A or B. The order does not matter. So this is the equation. We can circle that if we want. And then we can move forward to solve the equation. 8 squared is 8 times 8, plus 3 squared is 3 times 3. 8 times 8 is 64. 3 times 3 is 9. So we get 73 equals c squared. And that's where I'm going to stop, because 73 is not a perfect square. So it's going to be some fraction. It's going to be some decimal to make c. Because remember, c squared is c times c. And I cannot think of any whole number multiplied by itself to make 73. So today, this is where we are going to stop. Later in the module, we'll keep going, but this is where I want you to stop today, just finding c squared, finding the whole number. So hopefully you got that. Hopefully you checked your work with mine, and you're saying, yes, I got c squared equals 73, Mr. Baylor. And I'm going to say, well done. Example 4, we have an equilateral triangle. And so this is an example that I will do pretty quickly to show you what we can learn about an equilateral triangle. So what do we know about this equilateral triangle? We know that we have an equilateral triangle. Equilateral triangle means all the sides are the same. So let's say we know the triangle is 10 inches tall. What do we know about an equilateral triangle? Well, we know all the sides are the same. So every side is x. So if we know the triangle is 10 inches tall and every side is the same, every side is just going to be x, what else can we find out? Can we use this information to find the height? I mean, not the height. We know the height is 10. Can we use that the height is 10 inches and every side is the same x? Can we find a side of the triangle? Well, let's try it out. Let's just focus for a minute on 1/2 of the triangle, which kind of looks like that, but remember, it's not to scale. Now I know this is x. I know this is 10 inches. And this right here, the bottom is half x. Half x. Because it's the side cut in half for the bottom. So it's half x. Or you can say x divided by 2. Because it's x divided into 2 pieces. So if we just look at one triangle that makes up the bigger triangle, we can use the Pythagorean theorem to find what x is. So we know the Pythagorean theorem is a squared plus b squared equals c squared. We know the right angle is here. So I'm going to say that this is a, that's leg A, this is leg B, and the diagonal right here is the hypotenuse C. Remember, the hypotenuse is the diagonal that is opposite the right angle. So I'm going to use the Pythagorean theorem and a little bit of information right here to find the side of the triangle. A, remember, was 10, so 10 squared. B is x divided by 2, and then we square b, equals c squared, which is x. So c is x, square like that. Now we just need to use our properties to simplify and find x. So we know 10 squared is 10 times 10. X divided by 2 squared is going to be x divided by 2 times x divided by 2 equals x squared. 10 times 10 is 100. X over 2 times x over 2 is x squared over 4 equals x squared. Let's do minus x squared to both sides, x squared over 2 to both sides, x squared over 4 to both sides. So this is 100 equals x squared minus 1/4 x squared. So 1x squared minus 1/4 x squared is going to be 3/4 x squared, because this is 1 minus 1/4 is 3/4 x squared. Let's multiply both sides times 4/3 to get the x by itself, and I'm going to move my work up here now. So I get 400 over 3 equals x squared. So, and this is where I'll stop because I don't want to get too complicated right now. But you can see how I found out a number for the equilateral triangle. So not only does the Pythagorean theorem help me find missing parts of triangles, I can also use it to find missing parts of bigger shapes. So like for example 3, I found a missing part of one triangle. Example 4, I found out what the equilateral triangles are. I figured out more information. So the Pythagorean theorem is super useful if you can divide shapes into triangles. It can help you find missing pieces. That's what we're doing today. We're just finding missing pieces. And you're using the Pythagorean theorem or the converse of the Pythagorean theorem. That basically means sometimes the hypotenuse will be missing and you have to find C, or sometimes a leg will be missing and you will have to find the missing leg. Just use whatever, you're just using the Pythagorean theorem, either finding C or finding one of the legs. There are a few exercises to practice this. Let's see how many. There are 3 exercises, and all of them are like examples 1, 2, and 3, so you don't have anything like example 4. What I'd like you to do right now, pause the video again and try to do exercise 1 on page 2 and exercise 2 and 3 on page 3 and see how you do. See if you can use the Pythagorean theorem to find the missing sides. Unpause the video when you have your answers and you're ready to check your work with mine. Okay, so hopefully you paused the work and you did the exercises. Let me do the work again here so you can check your work with mine. So right here we have used the Pythagorean theorem to find a whole number estimate of the length and explain why your estimate makes sense. So let's do this. Let's do exercise 1 right now. So you looked at exercise 1. And the first thing you should have found is you should have gotten your you should have identified your legs and your hypotenuse. Legs and hypotenuse. So here's the right angle. So here's a leg next to the right angle. Here's another leg next to the right angle. And here's the hypotenuse. I'm just going to put H, or I'll put hip for hypotenuse because I don't want to write the whole thing. It's the diagonal across. You can even use the letters. The legs are A and B. The hypotenuse is C. And you should have used the Pythagorean theorem, which is A squared plus B squared equals C squared. And you should have looked at this and said, okay, what's missing? Well, B is missing for me. So I want to get B by itself. So I'm going to take away the A squared from both sides, subtraction property of equality. That gives me the B squared by itself. B squared equals C squared minus A squared. Because the B is missing, I want the B isolated. Now we substitute. B is what's missing, so that stays B. C, the hypotenuse, is 11. A, the leg, is 6. 11 squared is 121. 6 squared is 36. So 121 minus 36 is 85. So we get b squared equals 85. Well, we cannot really get b by itself. So it's okay if you stopped here. It's okay if you stopped here. You should have got b squared equals 85. But what about just b by itself? Can we make a guess about what b is close to? That's why I did the wiggly equal sign. What's a guess for b? What's a guess for b? Well, let's look at this. We know b squared equals 85. Well, I know 9 squared equals 9 times 9, which is 81. I know 10 squared is 10 times 10, which is 100. So what is b? Well, we know that b squared is 85, and 9 squared is 81. 10 squared is 100. So we know b has to be bigger than 9 and we know b has to be less than 10 because b squared is bigger than 81 and smaller than 100 because b squared is 85. So does that make sense to you? Look at this. I know 9 squared is 81. I know 10 squared is 100. B squared is somewhere in the middle. B squared is 85 in the middle. Now, it's not going to be 9. It's not going to be 10. It's going to be a decimal in between 9 and 10. But we don't know. But what's it going to be close to? What's it going to be close to? Well, 85. Is 85 closer to 81 or closer to 100? 85 is close to 81. So b is going to be close to 9. You can say that. b is going to be close to 9. It's going to be 9 with some decimal pieces. Because it's not 9, because 9 squared is 81. And it's not going to be the next whole number. The next whole number is 10. 10 squared is 100. So b has to be somewhere in between these because 85 is in the middle, so b has to be in the middle. So we can make a guess about, we know b squared is 85 because that's what the Pythagorean theorem told us. We know b squared is 85. But b by itself is going to be close to 9. Let's check exercise 2. Doing the same exact thing. Same exact thing. Using the Pythagorean theorem to find the whole number estimate. So again, here's the 90 degrees. So this can be leg A. This can be leg B. And the hypotenuse is always the diagonal opposite. So that should have been C. So you should have labeled your triangle A, B, C, or you could have done A, B, C. The important thing is this has to be C. This is the hypotenuse. It has to be C. So if you did that, you should have used the Pythagorean theorem. A squared plus B squared equals C squared. And C is unknown. We know A, we know B, so C is already isolated. So let's substitute. A we said was 6. B was 10 equals C squared. 6 times 6 is 36. 10 squared is 100. C squared. So that's 136 equals C squared. That's what C squared is. But what happens if I just want C? Well, unfortunately, 136 is not what we call a perfect square. Something times something to make 136 is going to be a decimal. So maybe we can just get close to 136. So think about the squares we know. We know that C squared equals 136. Well, what do we know? Well, I know two squares. I know that 11 squared, 11 times 11 is 121. And I know 12 squared, 12 times 12 is 144. So I know 136 is bigger than 121 and smaller than 144, which means c squared is bigger than 11 squared and smaller than 12 squared, which means c has to be bigger than 11 and smaller than 12. Because I know these multiplication facts, I know c squared is in between 11 and 12 squared. So c is in between 11 and 12. But what is it closer to? It's going to be a decimal. It's going to be 11 point something. But is that something closer to 11 or closer to 12? Well, looking at 136, 136 is 15 away from 11, and it is 8 away from 12 squared. So I'm going to say c is going to be closer to 12 because 136 is closer to 144. And that's all you have to get today. You just have to get the c squared, and you just have to get close to c. You can find c squared, but we just want you to get close with c. And this shows me how you get close. One more exercise to practice, so let's go for it. Number 3, Pythagorean theorem again. So you should have, again, found your legs, A and B, and found the hypotenuse, the diagonal, C. Then you use your Pythagorean theorem to find the missing side. A squared plus B squared equals C squared. Well, what's missing? B is missing. So let's isolate B. Let's get B by itself by using the subtraction property of equality. We get the b term by itself, so we get b squared equals c squared minus a squared. So we're going to have to write an equation for the converse of the Pythagorean theorem, because instead of finding the hypotenuse, we are finding a leg. Now we substitute. B is b, c was 11, a was 9. We use our math facts. 11 times 11 is 121. 9 times 9 is 81. 121 minus 81 is 40. So we know that b squared is 40. But I cannot think of what times what makes 40. I don't know. What times what makes 40? It's going to be a decimal. And we know it's not a whole number. I know that b squared equals 40. I know that 6 squared equals 36, because 6 times 6. I know 7 squared equals 49, 7 times 7. So b squared is bigger than 6 squared and smaller than 7 squared, because the 40 is in the middle of 36 and 49. So b squared is bigger than 6 squared, smaller than 7 squared, which means b is bigger than 6, smaller than 7. So b is bigger than 6, smaller than 7. It's going to be some decimal, 6 point something, 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 something. But what right now, maybe later in this module, we'll find the decimal answer, or maybe you'll learn how to do that in high school. But what we're doing now is I just want to get close. So is b going to be closer to 6 or closer to 7? Oh, I should make this wavy because we're not going to find the exact. Well, 40. 40, is that closer to 36 or closer to 49? It is closer to 36. So b is going to be close to 6. Is it going to be 6 exactly? No. Because 6 squared is 36. It's not going to be 6 exactly, but it's going to be close to 6. And that's what you're doing today. You're using the Pythagorean theorem to find the b squared term, and then you're finding out what it's close to. Because not all triangles are perfect. Not all triangle sides are whole numbers. Some triangles have decimal sides. And that's what we're talking about in today. We're talking about triangles where the sides are decimal measurements. In this module, we're going to talk about what you do. Like right here, we say b squared is 40. What do we do when we take the square roots? That's what we're going to talk about tomorrow in lesson 2. But today is just some practice with the Pythagorean theorem and getting close to side lengths. You're not going to find them exactly, and you don't have to. Just do your best to get close. Page 4 of this lesson is the lesson summary you can look at. Page 5 is the exit ticket. Let me slide that to the back. Page 7 and 8 is the 7, 8, and 9 are the homework helper pages if you need a little bit more guidance and some examples. Your problem set starts on page 11. I think it's a couple pages. Pages 11, 3 pages, I think. Pages 11, 12, and 13 are your problem set. And remember, my answers to the problem set are on the Google Classroom, so you can check your work with mine. When you've checked your work and asked all your questions, you're ready to work on the exit ticket. So remember, work on the exit ticket. There are 2 questions on the exit ticket. They're both exactly like what we've been doing today, finding the missing sides and getting as close as you can. Just give me an estimate. Using evidence. And then turn this exit ticket page in so I can see that you have learned the skill in lesson 1. That's what we're doing today. Practicing with the Pythagorean theorem and finding missing sides when those missing sides are not whole numbers. Good luck, have fun, and persevere.